Hey, welcome back everybody. Today on my channel we are going to continue the Pontiac 350 build. See it right here. We'll finish up the cylinder heads and start buttoning this thing up. All this stuff was filmed previously, so I hope you enjoy this. Here we go. Okay, so now the next thing on the Pontiac, guys, you remember I talked earlier about how that they on the 350s, they did not drill this bolt here. The problem that we have with that is this. On a lot of the engines, the exhaust manifolds and even the headers, if you look at the end of the header here, we've got this bolt here, and then of course we've got this bolt here, which is down here on the end. So that header's going to go on there just like that. So we want to make sure that this hole is exactly where it needs to be based on the headers we're putting on here. And so what I'm going to do is I'm going to bolt this header on to the existing bolts, and then we're going to lay that out and center punch it so we can drill this where it needs to be. So we measured the diameter of that hole there that's in the header, 30. So we're just going to go to 215, which is half of that. And that's going to put us right in the middle of that hole there. We're just going to make a mark in the center. And now we have a reference point. And if I measure that, perfect. Exactly in the center. And we'll do the same thing on the other side, then we can drill it. The other thing is, before you drill these, my advice is, man, don't ever do this with a hand drill. Have a machine shop do it that has a machine, because now this is a precision level good to 2/10 of a thousandth, and it's pretty sensitive. So we're just leveling this, and we're gonna lock it. So now we have leveled this so that our cutting head is exactly square to this surface. If you do this with a hand drill, you could get that bolt drilled crooked, and you're going to be in trouble if you do that. That could actually render the, well, I don't know if it'll make the head junk, but it's sure going to cause you some problems for sealing up that header, right? You can't guess certain things in life you can guess at. This is not one of them. You can't guess at this. It has to be completely square. We have all kinds of equipment and tools for leveling at this precision level here. Have a machine shop do it. Trust me, that's what you want to do if you got to drill these. All right, so we've got our drill bit lined up there, right where we center punched it, and we're just going to go ahead and drill that. That's our center punch hole, and we're going to put an 8-inch pilot hole in there. Now the thing is, when you drill this hole, you're going to punch through into the head bolt hole, and that's fine. Not a big issue. Okay, we just punched through down into the head bolt hole here, and that's fine. In fact, the heads that are drilled from the factory here, they actually drill through the head bolt hole there. They just don't run the threads all the way down. All right, so the next step is to get that bolt out to the right size for our tap. And this is a 3/8 tapped hole, so we're going to use a 7/16 drill bit, which is 312 thousandths in diameter, and that's the correct size for tapping that hole. Set my tap up with the machine. You don't want to, I don't really like to eyeball this. But I'm not going to use the machine to tap it, because then I'd probably break the tap. But I usually like to just get that tap started. So we'll go real slow here. We'll just get that tap in a few threads to make sure it's straight. And now we've got our tap in, we can go ahead and tap this. Alright, so there you have it. This is a 3/8 bolt, same size as the header bolts. And now we have corrected that problem, not having that extra bolt hole. So I'll do the other side and then we'll move on. So, on the Pontiac heads here, something I want to point out. When you buy aftermarket components like retainers from comp cams or whatever, this is a hardened steel retainer. The thickness of the retainer is a little different than the stock one, and also the location of the retainer can be a little bit different, not to mention the fact that we're using a high lift cam in this. So one of the things that you got to think about here, this is our retainer and our valve and our keeper setup that we're going to put on here. When they say in the catalog, when you buy these parts, that machining of the cylinder head may be required, there's a footnote there. They're not kidding. So here's the issue that you run into. So we have to take a measurement from the spring pad down here where the spring sits to the bottom of the retainer. And we use a special set of calipers to do that. And what you're doing, you guys, is you got to make sure that when that rocker pushes this valve open, that the bottom of the retainer here does not smash into the top of your guide or your valve stem seal, because we're increasing the lift. With stock lift, the stock Pontiac cam, I mean, it barely opens these valves. I think the lift is just under 400 or something crazy like that. Well, if we had a cam like that, it would be no problem. But since we've increased the lift here, what's happening when we took our measurement is the retainer is going to smash into that guide. That's a pretty big problem, because I mean, we're upgrading the springs and we're putting a dual spring setup on here with a lot more spring pressure for our roller cam and also a lot more lift. You notice on performance springs, if you look at the coils are really far apart. And that's mainly because we have to have more lift capability before we coil bind or anything like that, anything catastrophic. The other issue is where the spring sits. So the spring has to, when the spring is installed on the head, there's an installed height here. When it is compressed in between the spring pad and the retainer, there's a height. So in this situation, we checked the height, and the height wasn't quite big enough. In other words, our springs are a little bit too tight. So what we're having to do, not only do I got to cut the guide down so that the retainer doesn't smash into it with our lift. In this situation, and this happens sometimes depending on the factory casting, we're having to take about 30 thousandths, which is not a lot, but we're taking about 30 thousandths off the spring pad because the spring is just about 30 thousandths too tight. And we have special cutters that are designed to do this. This is for the spring pad, and there's a special radius on here. You got to use the right tool because the radius on the edge of this is really important. You don't want a sharp edge down here. And then of course we have another cutter that goes on there, and that is just going to cut our guide down. Now we've already cut these here. I got this last one here. I'll just kind of do a demo and show you how we cut that so you know what we're talking about. So that's what they're talking about. On some of these cylinder heads, when you buy performance parts, you have to do some machining on the head to make these parts actually work correctly. And you got to pay attention to this, because if you don't, I mean, if you put it together without checking these things, you would have your retainer smashing into the top of that guide, and that would be very bad. That would be a catastrophic failure. We definitely don't want any catastrophic failures. All right, so we've got our tool, our spring pad tool over our pad. So what we're going to do is we just go in and we're going to touch off of that, and then we're going to set our depth. So we're going to go till we just skim cut that spring pad, and that's going to be our starting point. Okay, so you can see we've just started getting into the spring pad, just skim cut it there. Now we need to go down 30 thousandths. So we're going to take a 30 thousandths feeler blade, and we're going to set our stop up here on the machine, and it's only going to let it go down that far. That's 30 thousandths. That's not much, but it does make a difference when you are setting up your valve springs. All right, here we go. We got the stop set, and we're just going to cut 30 thousandths here. 30,000. I know that looks like a lot of cutting, but it's actually not very much at all. All right, now the other issue is our guide height. You can see we've cut these down. I don't know how well you can see that on camera, but this one's quite a bit lower. About 100 thousandths is what we're cutting that down, which is what we need to get to make our lift work. So we're going to go in with our tool here, and you'll see we've already cut these initially. I'm just going to go down until I hit the top of the guide, and then we'll set our height. Okay. I use a drill bit that's 100 thousandths in diameter to set my stop up here. So we don't want to take too much off. All right. Now let's trim that guide down. All right, so there you have it, guys. That's what we end up with, and that's going to allow our installed height to be correct, and also we trimmed down the new guides we put in, and that's going to allow our rocker to open that valve without any kind of conflict between the retainer and the valve stem in here. So now that we've got these done, this head's pretty much done. We can start assembling it. Okay, also you guys, from my initial measurements, I'm fairly confident that we cut these down enough, but just because I want to make sure this is right before I take this off the machine, I'm going to measure from the bottom of that retainer to the top of my seal and see how much, the valve is closed right now, see how much lift capability I have here. So I'm going to touch off on that seal. I'm just going to go up to the bottom of the retainer. So that's the distance right there between the seal and the retainer. And I have, between the bottom of the retainer and the top of the seal, I have 680 thousandths. My lift is way less than 680, so I know that that retainer, when the valve opens, is not going to hit the top of that seal. So we're good. We're happy with that. So that is how you check that. And also our installed height here. Also on our installed height, so we cut these down. Now, I don't know how you can see that, but we took our installed height gauge here. We were at 570, which is way over here, which is too tight on that. And you can see we cut this. Right now we're at about 608, where we need to, 600 plus or minus about 8 or 10 thousandths is where we need to be. So that's really good. So that's going to put our spring in the range where we have the right pressure by installing it on the head with no shims or anything. So I've checked all these, they look really good, and we're right around 600, 1.600, which is perfect. So now that we have verified that we've got our guides at the right height and we've got our spring pads cut to where they need to be, now we just clean the head up and put it together. Okay, so now the other issue here, guys, is the studs. Now these are ARP rocker studs, and as some of you have probably figured out already, I've got the factory guide plate back on there. Now I know I told you never use this, it's a piece of crap, and honestly that was my opinion. The issue is they don't really make a rocker stud. This stud has a 1/2 inch lower on it, and nobody really has a guide plate for it. Comp cams, I was on the phone with Comp Cams, I was on the phone with Crane Cams and Butler Performance and all these companies, and they're basically like, well, what Butler recommended is the 1/2 inch holes in here, helicoil them and use the smaller stud in here. Well, I was gonna helicoil these and use the smaller stud on the lower end, but when I measured the holes that we pulled the press-in studs out of, they were a little bit too big for the helicoil tap, and I was like, oh man, I don't know if I like that or not. So anyway, I was on the phone with Butler trying to figure this out, and I mentioned, I said, hey, you know, I don't want to use the stock guides because they're crappy, you know. And the guy I was talking to at Butler, he's like, what are you talking about? And I said, well, those little sheet metal guide plates, I don't really like them. He goes, there's nothing wrong with those. He said, we've used those lots of times. He said that they work perfectly fine, and that there's really not a lot of stress on this plate here. All it does is just kind of guide, line up, and align the push rod. And so, you know, I guess I take back what I said. I mean, the guys at Butler, they probably built more Pontiacs in the last year than I've done in my life. So I just like the hardened steel guide plate, but according to them, this is no problem and you'll never have an issue with it. So I went ahead and took their recommendation, and I was able to use. Now, one of the things that is an advantage here is we got a big beefy 1/2 inch stud here on this side, and it's an ARP stud, so you know it's going to last. And also a 7/16 upper, which makes the rocker arm stability. There's been a lot of dyno tests with roller rockers and such, and actually the biggest difference that they've found in dyno tests is not going from a stock type rocker to a roller. It's actually going to a bigger stud here. So these are the one thing that I'm very proud of on these heads is the fact that we got these studs in here, because these studs are absolutely epic as far as their strength and stability. So yeah, so that's the dealio. So, but they're pretty much ready to assemble. I got all the heights right, the spring pads cut, got all the studs in. It was a little bit of an adventure, but we got her done. So, and the valve job and the milling's already done on these too. So basically it's just set up the valve spring heights and assemble them. And once I get that done, we'll come back and we'll go get back in there on that short block and start figuring out push rod length and rocker ratio and all that good stuff. Okay guys, so earlier we cut the spring pads down because our springs were too tight. So this is our new valve spring setup. It's a dual spring setup from Comp Cams. The installed height here is 1 inch 600 thousandths. When I put these on initially, before I cut the pads down 30 thousandths, they were about 570. So the distance from the bottom of the retainer to the spring pad was 1 inch 570, which was making the spring too tight. The installed height, the spec installed height is 1/600. They all turned out really nice. I measured all of them and they're all right around 1/600. So now we can just assemble our heads without any kind of shimming required. And of course also we cut the guides down to the point where we're not going to have any issues with the retainer. Once the retainer goes down here, I measured how far the valve opens. The valve opens, that was our goal in machining all that, is to make sure nothing collides. We have really good clearances here. And now that we got to that point, it's just a matter of assembling the head. I got the heads assembled. Now, you might be wondering why we left these two springs off. We put a couple of checking springs on here. We have to mount this on the engine, and we're gonna have to do some checking. We're gonna have to check our push rod length, and we're gonna have to also check our piston to valve clearance. The easiest way I've found to do it is just use a light checking spring so you can open and close the valve. And so that's why we have these here. The rest of them are assembled. Once we do the checks on our head, make sure everything is good clearance wise, we'll pull the head back off and put these last two springs and retainers on, and then we'll be in business. So the next thing is we need to go back over to the block. The heads are pretty much done with the exception of these two. We've got all our studs in here. Everything is set up correctly as far as the clearances go, and so the heads turned out really nice. I'm not going to do anything else today. I am burnt. I'm hitting about 13 hours right now on this thing, just on these heads today. So the next frame in the video is going to seem like it's instantaneous, but it will actually be tomorrow.